Hello everyone. We now present our research on scalable database normalization powered by the cloud. This is a joint work with several PGDBA students from ISI Kolkata. So we all know that with machine learning, we can solve a couple of problems, but then again, we face issues in several cases. On the other hand, with normal human intelligence, we can get advantage in a couple of those cases. So what if we can combine these machine intelligence and human intelligence to solve problems efficiently? So we basically introduce the approach of crowdsourcing, in which we employ the power of crowd, and then if it is combined with the power of machine learning, we can solve a lot of issues. So in this crowdsourcing, what we do basically break the computational extensive tasks into smaller microtasks, and then they're performed by the humans, which are nothing but the crowd with little or no prior experience. So if we have this kind of advantage with us of combining human intelligence and machine intelligence, what if we think about the problems that arise in database management system? So dealing with the data with this kind of crowdsourcing becomes an important concept. So we are particularly interested in talking about functional dependencies in a database. So our motivation is to find out a scalable approach with crowdsourcing with which we can identify functional dependencies in the data so that we can deal with normalization issues. So still there are challenges, like just because crowdsourcing uses a microtask, if we cannot make it private, if the data becomes open, that becomes a major issue. So how encryption of the data can be done so that the microtasks that are given to the crowd doesn't reveal the data, then it can be the best approach to deal with data privacy. So we basically use the concept of churn of spaces to convert data into a form so that people do not understand just by looking at a face what is there in the background as a data. So there are several approaches by several people in dealing with database management issues with crowdsourcing, but there was no explicit approach like this normalization issue earlier. At the same time, I mean, people didn't think about this kind of game-like structure to solve this kind of database problems. So from that perspective, it's going to be a new thing that we are presenting here. So we use the term microtask to point out this kind of small tasks that I just pointed out. So they are occasionally defined as HIT in a formal crowdsourcing platform. And channel spaces are nothing but a high-dimensional conversion of a high-dimensional data into a simple human face, where just by looking at the face features, we can tell what are the characteristics of the data. Look at there, we can ask a simple question like whether the nose in the phase 2 is bigger than the nose in figure 11. So in this way, we can understand whether the data has a greater range than the data in the other table or not. So in this way, if we can convert the values of the variables into different features of the faces, we can easily be sure that the data encryption is actually maintained. So functional dependency basically points out some relation between the attributes so that we can identify whether tuples are uniquely identified or not. So just by looking at the values for a pair of tuples, we can be sure whether they have some sort of functional dependency or not. So what if we convert these values into channel spaces so that every variable is getting converted into some features there, and just asking questions to the crowd about the faces and be sure whether there is a dependency between the values to be sure about the FDs. So we basically employ some existing methods so that we get a subset of the FDs without depending on the entire data and all possible combinations of the FDs. We take some inputs from the existing automated approaches, and then we employ the human intelligence to be sure whether really these FDs are the true FDs or not by posing them as HITs and asking the crowd the questions whether you see some similarity in the faces or not. So our results show that it's a novel and innovative way of discovering FDs. But the problem is, like, just because channel spaces has several features which are more visible than the other features, we can incorporate some sort of domain knowledge so that it becomes much more efficient to answer these kind of questions. So data security and privacy is certainly maintained just because we see the faces, not the exact data or the attributes there. And just because we use some sort of existing methods to have a subset of FDs as a starting point, we can deal with the scalability issue. At the same time, just because we employ enormous number of crowd on a popular crowdsourcing platform like Microtask, we can get rid of this kind of scalability. But remember that channel spaces is not the only approach to do the thing. we can think about other alternative visualization approaches. So the fun that we gain here could be one of the incentives, or we can think about other ways of incentivizing people. But the interesting stuff is that we can always pose this kind of problem as a game-like interface. So remember that channel spaces cannot be used if the number of attributes is more than 24. So I told you that for those cases, you can think about some other kind of visualization approaches, not only depending upon the channel spaces. So this research basically keeps a new avenue open for possible research in this direction, with which we can think about many other visualization to solve many other problems. But the problem is, like, if the a particular variable is having multi-level categorical value, then obviously we cannot directly convert it to a feature space in channel space. But we can think about some sort of encryption with which we can mask the data and frame the tasks using an HIT. So these are the important references. Thank you. If you have any questions, you can ask now.